This lesson is a second lesson examining binomial theorem, expanding that pattern a plus b to the power of n. As you can see on the screen, I've got the two things that we focused on last lesson. The first one being Pascal's triangle to determine the value of the coefficients. And the second one, the patterns that we follow in order to expand any binomial. So to quickly recap an example from last lesson, let's look at 2x plus 1 to the power of 3. So our process was that in order to determine the coefficients, we look at the third line knowing that it starts at 0. So this is 0th line, first, second, third. The second number will be the same as the power. So 1, 3, 3, 1 is our coefficients. That's the first part of our expansion. So if we put our coefficients in, that sets us up initially. The pattern is that the value that's in the space of A starts at maximal power and decreases incrementally down to a power of 0. So for each of these terms, we've got 2x and starts with maximal power, so 3. We've got 2x to the power of 2, 2x to the power of 1, and 2x to the power of 0. And with the second term, the b term, which in this case is 1, it starts off with minimal power, so it starts off at 0 and increases to that maximal power of 3. All right, so that's our pattern. We can then go through that process of simplifying. So this one ends up being 8x cubed. 3 times 4 is 12, so 12x squared. 6x, and then 1. So that expansion becomes a lot simpler. We don't have to worry about expanding multiple brackets and combining and simplifying. It's just a matter of applying that pattern. Now the lesson today is simply about focusing on a general term. So there's two things that we're going to think about. The first thing that we'll have to do to determine a general term, and general term is just a fancy way of saying a rule to work out any term in an expansion. So the first thing is that we need to find a way to get the coefficients without having to look at the whole line. So we need a way to find the coefficients, and that'll be a nice easy calculation that we'll look at in a second. And the second thing we need to do is then we need a standard rule for working out what the powers of each of the A and B components are. Okay. So first thing we'll need to do is we'll define two variables. N will be the power that the binomial is raised to, and R will be the term that we're trying to find. Now the thing with R is it starts at 0. So we don't start at the first term, we start at the 0th term. So we go 0, 1, 2, 3, and so on up to n. The easiest way for us to find the coefficients is use something called a combination. Now I'm not going to go through the theory of combinations today, but we're looking at NCR, and the simple breakdown of NCR is that it is the number of ways we can select R items from N items. So a simple thing might be if we're looking at 3C2, then what this is saying is how many different ways can we choose 2 of the 3? So if we've got 3 things, how many different ways can we choose 2 of them? This is a way that we're going to use to determine the values for Pascal's triangle. So the first part of our rule is we're going to say NCR. So N is the power and R is the term that we're trying to find. We'll look how that works in a second. The second thing is that we need a standard rule for the powers of A and B. So when we think about A, we know that A starts at the maximum power, and as we go across, it decreases incrementally. So if we're looking at the first term, the 0th term, it'll be a maximum power. If we're looking at the first term, the term after that, it'll be one less. So for that power of A, we're going to look at it as A to the power of n take away r. And for B, because it starts at 0, and that fits in with the 0th term, as we go across, the power is going to be the same as r, so that means that we'll look at B to the power of r. Now if we tie all this together, it means that our general term, so if we're looking for a term of that expansion, A plus B to the power of n, then what we'll need to do is look at NCR multiplied by A to the power of n take r multiplied by B to the power of r. So that will give us a single term. Now the last thing I'll say is it's so much easier to write this NCR as NR. So you'll see in the textbook they use that form, NR. So that allows us to do the combinations and just write it in a nice, easy way. Now, because I'm not going to teach you the rule for calculating combinations, you probably want to know how to do that. So I'm going to show you on the graphics calculator. So on the graphics calculator, NCR is, so you have to hit the button Option and then across, so F6, and then probability, which is F3, and then you can see that there's NCR there, so F3 again. But if I wanted to type in 3C2, I would just go 3C2. And so that would tell me there's 3 ways to choose 2 from 3. So I'm going to show this in full, and then I'll show you for how we want to use it. So let's go back to our previous question. Let's look at expanding. So e.g., let's try to use this to expand 2x plus 1 to the power of 3. Right, so now using our general term, we're going to have all the way up to 3, right? So it's important to note that r will be 0, 1, 2, and 3. So it's going to be a 0th term, a first, second, third. If we go back up, we can see that. So this first one will be our 0th term. So here's 0, here's 1, here's 2, and here's 3. We should get the same thing using this binomial theorem. Right, so let's expand this out. The first one will be, looking at the general term, the power is 3, so it's 3C0, and then it's 2x to the power of n take r, which means we're looking at 3 take 0, and then b, which is 1 to the power of 0. We can do the second one, and it's now 3, 1, so we do everything the same. The only difference is r is 1. The next term, 3, 2, 2x to the power of 3 take 2, 1 to the power of 2, and then finally we've got 3, 3, so 3c3, 2x to the power of 3 take 3, and 1 to the power of 3. Now, in my opinion, you'd be a bit of a crazy person to do it this way, because we've got Pascal's triangle, we know that line, we know what the coefficients are. We don't have to type in and go, well, what's 3c3? Because from Pascal's, we already know that's 1. So this does the same thing. That gives us 1 times 8x cubed and 3 times 4x squared and 3 times 2x and then 1 times 1, which gives us that same answer, 8x cubed plus 12x squared plus 6x plus 1. But it's a long way to go about something we can do in a simpler way, and hopefully you'll agree. So the real question is, why did I bother teaching you this general rule? And the general rule, so we want to use this when we want to calculate a term separately. Okay, so really easy example. For x plus 2 to the power of 10, find the fourth term. All right. So really, we just need to be able to work out the little bits and put it together. So if we're looking at the fourth term, the first term is actually 0. So if we think about r, the first one is 0, then it's 1, then it's 2, then it's 3. So we're actually using r is equal to 3. We know from this that n, the power, is 10, and we're replacing a with x and b with 2. So all we need to do now is use our general rule, right? And so that term that we're looking for will be 10c3. It will be x to the power of 10 take 3. And it will be 2 to the power of 3. So we're just stepping straight into that general rule. This is obviously n take r. This is r. And those a and b terms. So if we look at 10c3, that's 120. So we've got 120 x to the power of 7 times 2 cubed, which is 8. So, and we've got 960 x to the power of 7. Right, so that's one thing we can use to find a term within an expansion, and that's probably a nice simple focus. So now we've got one last example for the expansion. X take 3y squared to the power of 6. Find the general term and find the coefficient of x cubed y to the power of 6. So the general term, we want to write the rule, and once we've written the rule, we can look at, well, what does r have to be for this to work? So general term, we know that n is equal to 6. So we've got 6 instead of n. R is still variable at this stage because we're just looking at the general term. This is a rule for all of the terms. Instead of a, we've got x. So we've got x to the power of n take r. So 6 take r. And our second term is this whole negative 3y squared. So now we've got negative 3y squared, and it will be to the power of r. Okay, so this is what we call the general term. In truth, it's all the terms. General is referring to a rule that fits all the terms. And the second thing we need to do is go, okay, so we want to find the coefficient of x cubed y to the power of 6. All right, so which one of these is going to end up as x cubed? What does r have to be for this to equal 3? Now that ends up being a pretty easy answer, right? If we want 6 take r to equal 3, then r must be 3. And as soon as we do that, it's just a substitution in to find the term that we want and then isolate the coefficient. So term is, this time it's 6, 3. We've got x to the power of 6 take 3. And we have negative 3y squared to the power of 3. What we need to do now is work these values out. So 6c3, that's 20. X cubed. Now we've got negative 3 to the power of 3, which is negative 27. Then we've got y squared cubed, which is y to the power of 6. So 20 times 27, so we've got negative 540, x cubed y to the power of 6. And there it is as our term, and this is the coefficient that we're looking for. So that coefficient, negative 540. All right, so this is not easy by any stretch. When you start working with a general term, it's definitely a lot more complex than just expanding out using Pascals. hopefully it makes enough sense for you to be able to calculate the number of combinations to get that coefficient and to be able to form a term, define a 5th term, a 10th term, a 100th term, a 50th term for whatever scenario we're looking at. Okay, thank you.